All right, Algebra 1, lesson 99, page 418, okay? Today we have door number 3, all right? Review just a little bit. We had door number 1, uniform motion problems, distance equals distance, picture looks like this, rate times time equals rate times time. When you're working these uniform motion problems, listen to me as I speak. Look at me. Figure out which one it is to start with. Draw the picture, label it, put this down. Door number 2 is distance plus distance equals a total. When you're working this problem, figure out which one it is. Draw the picture. Figure out what to call it. Is it going together? Is it coming apart? Is it going here and going here? Is it this picture? Label it. Use this equation. Subscript the variables. Put this stuff down. Okay? Door number 3 is what I like to call a head start. They call it unequal distances. So it looks something like this. Either we both start, let's say I'm going to race Lydia. We're going to run. I'm going to race Lydia from here to the church house. Okay? And so Carlos lines us up, and he gets the starter pistol, and Jade has the little timer thing, and Tucker is cheering me on, and Elijah and Grant are cheering Lydia on, and they already know who's going to win because I'm going to win. So we're standing right here together over here by the shop, and the pistol starts, the timer starts, and this is Lydia. She takes off. She's a little bit faster than I am. And here I am, and I start right here. Now, when she gets there, the timer stops. I'm still back here. I still have this distance to go. So my distance plus whatever distance that is the same as the distance that she went. Okay? Or we're going to do this thing, and I want to get there at the same time. So she starts at the shop, and I start over by one of the trailers that's over there by the church house. And when the pistol sounds and the timer starts, we both start running. Okay, and she's a lot faster than me, that we get there at the same time, and we click it off. Okay, does that make sense? So it's her distance is the same as my distance plus the head start I had. This is the equation. Rate times time plus some distance equals rate times time. Okay, so 99.1, it says at 8 p.m., Achilles left the camp and headed south at 20 kilometers an hour. At 10 p.m., the other guy, Pat, headed south from the same camp. If Pat was 50 kilometers ahead by 3 p.m., what was his speed? So we want to figure it out. It's going to be this picture here, okay? At 8 p.m., Achilles started. Yeah. Okay, so this is going to be Achilles right here. I just read you the picture. So here's Achilles, and at 8 p.m., he starts, okay? And let's see. And he's going 20 kilometers an hour. That's a rate. That's a rate, okay? And what's going to happen after that? At 10 p.m., Pat starts. So Pat down here starts in the same place at 10 p.m. If you think about it, that's 2 hours later, 2 hours longer, 2 hours later. Okay, he starts. If Pat is 50 kilometers ahead by 3 a.m. Okay, so now by 3 a.m., Pat is 50 kilometers out front of Achilles. Does that make sense? And this is at 3 p.m. This is also 3 p.m. Do you see all that? Okay, and we're looking to see what was Pat's speed. Okay, we're looking to find Pat's speed. So let's just start looking at stuff. Here's our thing. We've got A and A, because this right here, the 50 goes here, and down here this is P and P. Does that make sense? P travels the longest. Here's A. We know his rate, but he still has 50 miles to go because this guy is 50 miles ahead of him. All right, so let's just look at this. I know RA, the rate of Achilles is 20 right there. Now, what about times? Time of Achilles. How long did he travel? Well, when did he start? He started at 8 p.m., and this is it. Wait a minute, did that wrong. Got to be careful here. This is 3 a.m., okay? So from 8 to 12, 8, 9, 10, 11, 12, that's 4 hours plus 3. 4 plus 3 is 7 hours, okay? The time of Pat, he started at 10 to 3. 10, 11, 12, plus 3 is 5. He traveled 5 hours. Now, did you get what I just did there, okay? 8 p.m. to 3 p.m. is 7 hours. 10 p.m. to 3 a.m. is 5 hours. Now, I don't know what RP is. That's what I'm looking for. You still with me? So let's just put numbers in here. RA is 20 right here. Okay. TA is 7 right here. Plus 50 equals RP, that's what I don't know. RP and TP is 5. 5 toilet paper. So let's just solve this thing. 20 times 7. 7 times 2 is 140. Plus 50. It's probably about 190 equals 5RP. And because y'all are smart and wonderful and famous and all that stuff, and you have your calculators, if you take that 190, 190 divided by 5 equals and that's what they asked for. What is the rate of Pat? Okay? You got that. Now, you guys got to get a hold of this thing. They don't ask for this, but help me. How far did A travel? Well, here's the 2 A's. You get me? Here's the 2 A's. 38 times 20. Okay? How far did, I'm sorry, did I do that wrong? I did. Stop. Sorry. RATA right here. And RPTP right here. So the distance of Achilles, this distance is 20 times 7. That's 140 miles, okay? It's 140 miles, okay? This distance here is 140, okay? This distance, 140. This distance down here is 38 times 5. That's 190. Now watch. Just think this through. They didn't ask any of this. I just want you to see it. 140 plus 50 is 190. 140 plus 50 is 190 right here. Distance plus some distance equals distance. Okay? Let's run another one of these real quick. Okay? So you've got rate times time plus something equals rate times time. This could be in front of this or back. This is this plus, doesn't matter, okay? Next example, Harry and Jeanette. You'll like this one, okay? Because this one you really have to think. Jog around a circular track that is 210 meters long. From here to here is 210 meters. They're jogging around a circular track. Jeanette's rate is 230 meters per minute. Okay, while Harry's rate is only 200 meters per minute. Okay, how many minutes will it take for Jeanette to be a full lap ahead? So watch this. We want Jeanette to be a full lap ahead. So let's look at this. Okay, here's our pictures. we want Jeanette to be a full lap ahead. Okay, what's the other guy's? Is it Henry? Harry. Harry. Now here's the deal. How much is a full lap? Right over there. See it? That's 210. Okay, she wants to be a full lap ahead. I want to know how many minutes, how long, what's the time until she is twice as far ahead as him. She's lapped him once, getting ready to lap him again. Okay, Jeanette's rate is 230 meters per minute. Her rate, 230 meters per minute. Yep. And his is only 200 meters per minute. Those are the rates. Okay? We want to know how long it is. What's the time? We're looking for time. Now understand, this time and this time are going to be equal. All right? So here we go. Here's the short one right here is H. Okay? This is right here. This is Jeanette. Now what I do know is the rates. Yes? So I've got RH is 200. I should write better. RJ is 230. I don't care about distances. What I want is times. Now, what do I know about the times, though? Time of Jeanette, are they starting at the same time? It's a race. Yes. Are they ending at the same time? Yes. That means the times are equal. Does that make sense a little bit? Times are the same. They start at the same time, they end at the same time. It's a race, okay? The distances are not equal. So what you can do here is just get rid of that, okay? Because they're the same. So I don't care about that and about that on this one here. So let's just substitute some stuff in. So this here is 200. T plus 210 equals, this one here, J, 230. T, just like that. Okay, so the smallest one is this. So we subtract over here. So we have 210 equals 200, so we have 30 T, and so we divide, so that's 7 equals T. Okay, and those are minutes. So how many minutes does it take until Jeanette laps Harry, goes twice as far, one full lap ahead? It takes 7 minutes. All right? Pretty easy. Pretty easy. Watch. The secret to doing this is to read it. Draw the picture. Label the picture. Make sure you got the stuff. This is how far ahead they are or how far ahead they started right here. This guy travels this smaller distance, shorter distance. This person travels a longer distance. This guy is going to be going faster, and this guy is going to be going slower. Usually the time from here to here is the same. The times are usually the same. Okay? So just think this through. Not hard to do.